Hello class, today we're talking about equivalent fractions. The word equivalent means equal to. So when you see in your workbook or in some of the assignments that are posted the word equivalent fractions, we are talking about two fractions that equal one another. In other words, they look differently, but they are showing us the same amount of something. Okay, equivalent fractions. Okay, let's pretend that me and you want to share a cake, which is ridiculous because I wouldn't share a cake with anybody. But let's pretend for the sake of this lesson. Now, we have our cake drawn here on the board, and let's say that me and you want to split the cake into, and we're each going to have a piece. So we take our cake, we divide it in half. We each have an equal part of the cake. So each of us will get one half of the cake. So remember, our denominator, always on the bottom, is 2 because our cake is divided into 2 equal pieces. And our numerator represents what each piece is worth. So your shaded piece is going to be worth one of those 2 halves. But then you get greedy and you're like, well, you say to me, Bubba, I'd like to have 2 pieces of cake. So I say, okay. And I cut the cake again in half. And I give you your 2 pieces. Now when I cut the cake in half again, did you get any more cake than when you would have had before? No, you didn't. You had got the same amount of cake. The trick is I cut the cake up again, so instead of now the cake being cut into 2 pieces, the cake is now cut into 4 equal pieces. So our denominator's changed to 4. You got 2 pieces, 1, 2, but you got the same amount of cake. You didn't get any more cake. So what this picture and what this demonstrates for us is that 1 half is equivalent or is equal to 2 fourths. They represent the same amount of the cake we're cutting up. Let's look at it this way. Maybe you want to have more than that, and so we cut this cake up some more times. So now we cut the cake into 1, 2, 3, 4, 5, 6, 7, 8 equal pieces, and you get 4 pieces. You still have the same amount of cake. You're not getting any more cake. Forget about it. You have the same amount of cake. But now this time you have 4 pieces. They're a little bit smaller because we've cut them up into smaller pieces to give us a new fraction. We have 8 pieces in our cake, and you get 4 of them. Again, all of these fractions are equivalent to one another. They all show us that we're not getting any more cake. We're just changing up the pieces, the size of the pieces that we're getting. And so that changes the fraction, changes the denominator, and therefore it changes the numerator. Now I've taken the picture away, and we're going to look at this by doing a little bit of a math equation. Well, this is math, so I guess that's fair. How do we do this without drawing the picture? Now the pictures always help us to visualize and see what this looks like, so that it helps us. They're a guide. But the pictures are only a guide. So what we want to do is figure out, how do we show that these 2 fractions are equivalent, or how do we make 2 equivalent fractions if we're asked to? So here's the trick, here's the secret math magic that will work for this equation. What we've done here, when I took my picture, and I'll just redraw it right here real quick. So I have my picture and I divided it in half. Okay, so now I have half. What I did here, by dividing it again, is I made 4 pieces instead of 2. So how do we get from 2 to 4? What do we have to do? What number do we multiply 2 by in order to get us 4? Well, that's an easy one. 2 times 2 is 4. Now the secret with making equivalent fractions is whatever I do to one of these numbers, so whatever I do to the denominator, I do the exact same thing to the numerator. So if I multiply the denominator by 2, 2 times 2 is 4, then I must multiply the numerator by the same number, times 2. So whatever I multiply to get this, from here to here, I multiply the numerator, and it gives me the correct numerator on this side. So 2 times 2 is 4, and 1 times 2 is 2. So this is showing us that 1/2 is equal to 2 over 4. It's the same amount, okay, but the pieces are cut differently, but these fractions are equivalent. Let's look at these pictures on the board and we will create equivalent fractions for each one of these. We'll start with the first one on the top. This picture shows us the fraction of 1 over 3. So let's look at it. 3 is our denominator because this picture is divided into 3 equal pieces. And one of those pieces is shaded, but each one of these is worth 1, okay? So 1 over 3. Now let's divide this in half again. Let's put a line through here, divide it in half. Now remember, no one's getting any more pieces of my cake. All right, we're just cutting the cake up smaller. So now we have 1, 2, 3, 4, 5, 6 pieces of cake. And we have 2 pieces shaded in. So what this tells us is that 1/3 is equal to 2/6. It's the same amount. How did we do that? Well, let's do our math equation. What times 3 equals 6? Well, 3 times 2. Look, all I did was divide it in 2. So 3 times 2 equals 6. And remember what I just said, whatever I do to the bottom, I'm going to do the exact same thing to the top. So 1 times 2 equals 2. 3 times 2 is 6. 1 times 2 is 2. 1 over 3 equals 2 over 6. Okay, you got that one? Let's look at this one here. This fraction represents 1, 2, 3, 4 is our denominator, and 2 of those pieces are shaded in. But we're going to divide this in half. We're going to cut it in half again, giving us 1, 2, 3, 4, 5, 6, 7, 8 new pieces. Now remember, it's the same amount, only the pieces are different because I cut them up smaller, but they're all cut up into equal sizes. And we can see that now 4 of these are shaded in, and we can say that those are equivalent fractions, they're equal. Well, 4 times 2 is 8, and 2 times 4, or 2 times 2, I'm sorry, is 4. So whatever I did here, I do here, okay? That'll work every single time. This fraction is 1, 2, 3, 4, 5, so 5 is my denominator, and I have 3 of those pieces shaded in. And I'm going to cut this cake again in 2. So now 1, 2, 3, 4, 5, 6 pieces are shaded in. What do you think our denominator is going to be? Well, instead of counting it, let's just do the math. 3 times what equals 6? 3 times 2. Whatever I do to one side, I do to the other. So whatever I do to the numerator, I do to the denominator. Or whatever I do to the denominator, I do the same thing to the numerator. So if 3 times 2 is 6, then 5 times 2 is exactly 10. Which means that 3 over 5, or 3/5, equals 6/10. And the picture shows us that this is true. These, if I asked you, if I gave you 3/5 of a piece of a cake and I gave someone else 6/10 of a cake, who got more cake? Well, the truth is that neither of you got more. You've got the same amount. You have the same amount of cake. One of you has bigger pieces and you have 3 of them, and one of you have smaller pieces but you have 6 of them, but you each have the same amount. Remember how I said months ago that it's very important that you have your multiplication times tables memorized. And this is why, because when we're doing fractions, it's important that we have these facts, these math facts, memorized. So because now we're not drawing pictures anymore. Now we have to do some math. So it's very important. So even though we're doing online learning, and even though we're doing lessons this way, continue working on your times tables and your math facts, because those are going to come in handy for you for your whole life. But let's look at these fractions. How do I get from 5 to 15? Well, I have to multiply 5 times something. Well, 5 times 3 is 15. 5 times 3 is 15. So whatever I do on the bottom, I'm going to do to the top. So 1 times 3, okay, because that's what I did here. I'm going to do the same thing. 1 times 3 is 3. So without drawing a picture, we can say that 1/5 is equivalent to or equal to 3/15. They're the same amount of cake. They're the same amount. Let's look at the next one. 3/4 or 3/4 or 3/4 is equal to what over 16? Well, 4 times what gives us 16? 4 times 4. 4 times 4 is 16. Whatever I do to the bottom, I do to the top, which means 3 times 4, same thing, is 12. So 3/4 is equivalent to 12/16. So while we're doing this, picture this as a picture, or draw it. Maybe draw these out if you want to prove that this is correct. Okay, but this is how we do this by using multiplication and this little trick of doing the same thing to the top and bottom. Now, let's look at this one. 5/6 equals how many 12s? Well, let's start here. 6 times what is 12? Well, if you know your 6 times table, you'll know that 6 times 2 is 12. And since we did that on the bottom, we're going to do the same thing on the top. 5 times 2 is 10. 5/6 is equal to 10/12. Again, equivalent fractions. They are the same amount. They represent the same pieces of cake. Let's look at the next one, last one. 7/10 equals what over 100? Without doing the math, I'm sure that most of you can guess what this is going to be. But let's do it anyway. 10 times what number is 100? 10 times 10. So that means 7 times 10 equals 7 times 10, 70. 7/10 equals 70/100. So when it comes to fractions, remember, fractions represent or show us parts of a whole thing. So if I have a cake that is divided into 100 pieces and I give you 70 of them, I didn't give you the whole cake. I only gave you a fraction of the cake. So remember, fractions are part of a whole, and because of that, don't let the size of the fraction fool you into thinking it's bigger than another fraction. So in this case, 12/16 looks like a bigger number than 3/4, but we've proven it isn't. They're equal. They're the same amount. It's just that you cut the denominator up into smaller pieces, which means that the numerator also changes because of that. Now, instead of having 3 pieces, you have 4 times as many pieces cut up, but you still have the same amount, equivalent amount. We'll do one more round of these, but now I have the numerators filled in and not the denominators, just to show us that we can do this both ways. So again, we're going to start with our first fraction, 3/4, 3/4, is equal to 15 over what? Well, let's just do the simple way of multiplying 3 times what equals 15. Well, 3 times 5 is 15. And whatever I do to the top, I'm going to do to the bottom. So I multiplied the top by 5. I will multiply the bottom by 5. So 4 times 5 equals 20. 3/4 equals 15/20. 5/6 equals 30 over. So what did I do? I'm not going to write this one in. Let's just talk this one through. 5 times what is 30? 5 times 6 is 30. So that means 6 times 6 is 36. Okay, so I'll write it in now. 5 times 6 and 6 times 6. So you can see this is very, very simple. As long as you know your multiplication, it'll be very quick as well. If you're unsure in your multiplication, get out a cheat sheet and figure it out. Or you're home, get a calculator. Let's try this one. 1 times 7 equals 7. So I have to multiply 8 times 7. Remember, whatever I do to one, I do to the other. 8 times 7 is 56. Well, 1/8 equals 7/56. But if you looked at these two fractions, this one looks like a much larger fraction. But in reality, they equal the same amount. 4/10. 4 times what is 40? 4 times 10. So I multiply 10 times 10. 10 times 10 is 100 exactly. So again, this works both ways. Whatever I do to either top or bottom, whatever I do to the numerator, I also do to the denominator. And this is giving us equal or equivalent fractions, parts of a whole that represent the same amount. Okay, there'll be lots of assignments. No, there won't be lots, but there'll be a few assignments for you guys to complete. There'll be some workbook pages, and there'll be a couple assignments for you guys to do to keep working on this. Private message me if you're having trouble, or make sure you ask your parents for help. But I'm always here to help. And remember, we're going to have a Zoom class meeting on Thursday at 10 o'clock. So make sure that you add the app to your Google Chromebooks. If you have Google Chromebooks, you just go in and in fact, when I send you the link, it'll walk you right through all the steps you have to do. So can't wait to see you guys, and keep working on this, and we'll see you soon. Coconut milk braised chicken with sweet potatoes and rice. 'Cause I know that I let you down. Is it too late to say sorry now? Okay.